Hey, North, Mr. Yergler here. We're going to talk about dimensional analysis. This is just going to be a real basic introduction to it. Most of you have already seen dimensional analysis before, and so just kind of a quick refresher. These are going to be kind of simpler dimensional analysis, one-step problems. We will jump into multi-step problems very shortly. So we'll start small with these single-step problems, and then we can start tackling the bigger ones. We're going to actually use dimensional analysis now to calculate a number of moles of particles in a sample, or an amount of atoms, or a molar volume, or something like that. All right, let's get started. Just some quick pointers, just a summary of the steps. We're always going to start with a number, start with what you're given, and I often just leave it over nothing. It's essentially over 1. Which obviously doesn't make a difference in the calculation. We're always multiplying by a fraction, a conversion factor, you could call it, or a ratio, or some sort of relationship from one unit to another unit, right? Like how many inches per foot, right? That would be a relationship or a conversion factor that you could use. We're always going to place our conversion factors so that our units cancel out, and we're going to multiply numerators and divide by denominators. Now, these are some of the key conversions and key numbers that you need to know and have down. This is a great way to represent how molar conversions work. Everything goes through moles, right? So if you start with mass, you have to get to moles before you can go to volume. Or if you have volume, you have to get to moles before you can go to particles. All right? This is another way to represent the same thing. So kind of a good way to visualize and kind of plan out your steps, especially when they're multi-step. Let's look at a couple examples. I think this will be better if I just write them out. We'll start with a practical everyday life kind of example. Let's say that gas is $2.54.9 a gallon, and your car gets your car gets 35 miles a gallon. What's the cost of driving 15 miles? Now, there's a couple numbers given here, and a couple of them are conversion factors, they're relationships, and one is actually your given. The given is the 15 miles, right? Because that's kind of what we're concerned with for this particular example. So let's start with the 15 miles. And I'm just going to abbreviate. And like I said earlier, you could put this over 1. It doesn't really matter. Now, my conversion factor, I need a relationship to go from miles to eventually cost, which is just going to be dollars. Let's kind of draw this out. This is actually a multi-step problem, which is a little more complex, but it's it's a simple example that can kind of help see the value of the dimensional analysis. If we go from miles, we can't go directly to dollars because we don't have a dollars to miles relationship. We do, though, have a miles to gallon relationship. So we can go to gallons, and then from there we can go to dollars, right? So that's kind of our flow chart of how we're going to do this. Miles converted to gallons, we need our miles to gallon relationship. So I'm going to put the 35 miles on the bottom and 1 gallon on the top so that my miles will cancel, right? 35 miles per gallon. You're used to maybe seeing it like this or reading it like this. You would really represent this mathematically like this, right? Miles per gallon. You could write something like that. All right, from there, we have one more step. We're going to go from gallons to dollars. Gallons has to be on bottom because I need it to cancel. And this is a price per gallon, so this is going to be 1 gallon. And my price is $2.54.9. Now gallons cancels, and we're left with just dollars. It's the only unit left, and so that's the unit on our answer. And 3 sig figs. Well, I guess you should have 2, but it's a cost, so it's always going to have 2 decimal places. So if you wanted to say $1.1, that would be fine. Let's look at another one, kind of jumping into chemistry contexts. Calculate the number of molecules in 4.37 moles of lithium sulfide. Let's go ahead and write a formula for this, just so we have it down. Lithium has a +1 charge, sulfide has a -2 charge, and so we need 2 of the lithiums and 1 sulfide to make a neutral compound. So this is an ionic compound, or a salt, a lithium sulfide salt. Now let's start with what we're given, 4.37 moles of lithium sulfide. And we need to go from moles to molecules. Look back at your molar map that I showed you earlier. That's going to be the 6.02 times 10 to the 23rd number. 1 mole has to be on the bottom, 6.02 times 10 to the 23rd on top, because we need the moles to cancel. And that's it. That gives us our unit that we need, and so just one step, right? Moles cancels. You really should be using your E button on your calculator to get this anytime you're dealing with scientific notation. If you forget how to do that or you want to refresh on that, there's videos in the 0 unit that you can look at. All right, now let's jump to calculating the number of atoms in question 1. This kind of adds another layer to it. We know that we have this many molecules, and I'm writing this out so that I can kind of see and double check my relationship between my number of molecules and atoms. How many atoms are in a molecule? Well, there's 2 lithiums and 1 sulfur. So there's 1 molecule has 3 atoms. So it's just going to be this number times 3. And you really, if you wanted to go directly to this question, you could have added this conversion factor in right here, and you would have gotten 7.89 times 10 to the 24th atoms. I want to go over this one because it's a molar volume example. Let's start with our given, 79.80 liters. And diphosphorus pentoxide, this is a covalent compound because they're both nonmetals, so this would be 2 phosphorus, 5 oxygens. At STP, all gases, no matter what they are 22.4 liters. That was in that molar map from a previous slide. So 22.4 liters is the volume of 1 mole. That's only at STP, so you can only use that when you see STP. 3.56. Some people will say not to limit your sig figs by conversion factors. Like conversion factors are exact often, and so they shouldn't limit your sig figs. And they can be looked up, right? You can look up the conversion from one unit to another to like tons of digits, and so you shouldn't limit yourself. But so I'm not gonna slap you in the face if you have an extra digit here. If you're not limiting yourself by this conversion factor, if you put 4, I put 3. So there's a couple of examples of simple dimensional analysis questions. Dimensional analysis is a skill that you have to have down. It's a skill that we're going to use in more complex situations, and so I really want you to focus on getting this down and being really fluent with it. You should be able to do it almost without thinking. This is Mr. Yerler signing out.